Reordering dataframe columns in Tidyverse can be done with relocate. The columns that are added as its arguments are moved in the beginning of the dataframe on the left and in the order they are given. First the column category and then the column name. In Julia you have more than one options for reordering columns. You can either use the calls column selector that picks and orders the columns based on the order of its arguments, namely first category, then name and then the rest, or with the select function that selects the two columns and then places them on the left, while the rest of the columns follow on the right in the resulting data frame. Our ladies also demonstrated how to reorder a column before or after a specific column. Here they reorder the column item underscore ID after name. To achieve the same effect in Julia, you need to be a bit more explicit and slightly more verbose, since you now use the between selector within calls to include all the columns between the first and name, then item underscore ID, and then the rest of the columns. To reorder groups of columns that belong to a single type, our ladies used relocate along with the helper function where. Here, relocate moves the columns that are of character type in front on the left. For moving the numeric columns, you simply need the is.numeric function. The names function in Julia accepts an extra argument to subset the column names that belong to a specific type. Notice that the R character type translates to the abstract string type in Julia. If you embed names within the calls column selector, as shown here, then you simply get the desired column order. The second option is to use select with the same idea of extracting an array of columns with values of a specific type, be it an abstract string or a real number. Notice the two underscores needed due to the embedded use of IKEA within names. One of the most important data wrangling skills is to be able to sort the rows of a data frame based on the values of one or more columns. Our ladies used the arrange function to sort all rows of IKEA based on the increasing order of the values in the price column. To sort price in the reverse decreasing order, you need to wrap the column name with the helper function desk. To sort IKEA by several columns consecutively, you simply add them as arguments to arrange. Here, IKEA is sorted first based on height, then on width, and then on depth. Julia has the sort function to achieve the exact same effects. First, to sort IKEA based on price, then in decreasing order by setting the rev argument to true, and lastly sorting based on multiple columns identically to R. To select a specific column, Tidyverse uses, fair enough, the select function. Notice that the resulting output is ordered alphabetically. To calculate some basic statistics of a selected numeric column, you can use summary. The output includes the values of the 4 quartiles and the mean. Julia offers its own select function, and you need to combine it with a sort bang function to get the same output with our select. While for basic summary statistics, describe displays a richer set of information, since apart from the quartile and the mean, it also includes the number of missing values and the numeric type of the column. Here it is float 64. Focusing on specific basic statistical indices, Julia and Kyla of Our Ladies showed how to use the max and min functions to get back the maximum and minimum values of the height and width columns respectively. Notice the keyword argument na.rm used for ignoring the na values when calculating the maximum and the minimum values. Julia outputs the same information in one step using describe that accepts 2 additional arguments apart from IKEA. The first of the 2 is the summary function that you want to use, max and min in our case, and the second additional argument is the named argument calls, whose value or values are the column or columns for which you want to calculate the maximum and minimum values. To extract multiple columns in R, you simply place their names as arguments of the select function, separated by commas. Notice that the extracted columns are placed in the resulting data frame in the order that you place the arguments. Julia has no difference with respect to colon extracting and the colon ordering. Its own select function does the same thing. The only difference being that it accepts colon names represented as either symbols, as shown here, or as strings, which means that quotes are needed.